Okay. I will start now. Okay. Hello. My name is Zulfian, and I'm joining remotely from Indonesia. I'm happy to be here at GUADEC after my first talk at Genome Asia Summit in Tokyo last year. Mr. Ramkrishna encouraged me to submit this talk to GUADEC. I'd like to thank him for that. So here I am. Today I want to talk about Jollpi. Like my text editor, I first built in 2010, and what happened when I tried to bring it to GTK4. Let me give a bit context about myself and this project. I started using Linux in 2008 through canonical CP program, getting Ubuntu CDs delivered to my home. That put me deep into the ecosystem. 2 years later, in 2010, I built Jollpi as a personal experiment. Python was not taught at my college. GTK was almost unknown where I studied. So I learned everything on my own, mostly from books and documentation. And that project became my thesis. After graduating in 2011, I stopped coding for a long time and returned to programming in 2024. And last year, in 2025, I rewrote Jollpi completely from scratch. One thing I found later, those early releases were downloaded from 23 countries on SourceForge. So for a small student, that was so surprisingly motivating. So here is a quick overview of what changed between the two versions. On the left, of Jollpi, use Python 2, GTK2, GTK.SourceView2, Genome Virtual File System for file handling, manual MD5 hashing for file monitoring, use iterator-based search, and no CSS system at all. On the right, Jollpi 2025 is Python 3, GTK4, GTK-SourceView5, modern Gio, Gio.FileMonitor, GTK-SourceContext, and GTK-CSS. So on paper, this looks like a straightforward upgrade, but when I actually open the old code and try to pour it, that assumption lasted only a few hours. The first thing I encountered was the application model. In GTK2, you start with a window directly. You create a GTK window, connect the distro signal to GTK main queue, call show all, and run GTK main. That's it. The window is the application. Now in GTK4, there is no GTK main anymore. Everything starts with GTK.Application. You define the application, set an application ID, and the Windows lives inside do activate. And the life cycle like startup, activate, shutdown is all managed by the application. So for me, personally, this actually made things easier. In GTK2, at that time, for me, creating a second window felt complicated because there was nothing holding everything together. Now in GTK4, a new window is just a new instance under the same application lifecycle. Everything follows automatically. But coming from GTK2, this was the first clear signal. This is not just a syntax update. The second thing I found was the menu system. In GTK2, the recommended way to build menus and toolbars was UI Manager together with action group. You define entries like actions, labels, shortcuts, callbacks, all in a list. Then you create an action group, add the entries, create a UI manager, insert the action group, add the accelerator group to the window, and finally get the menu bar widget from a path string. And for Jollpi, that list had many entries covering every menu item. In GTK4, UI Manager is completely gone. Actions are now registered using GO Simple Action, and menus can be built using GTK Builder, one system for both UI and menus. And I also create a small helper function, create action, to register each action together with its callback and keyboard shortcut in one call. And the helper is personal choice to keep the code clean, not a requirement. And beyond the technical chain, genome-modern applications follow a different UI pattern. Instead of a classic menu bar, Jollpi now uses a header bar with a hamburger menu pop-up. So more focused and cleaner. So within the first few hours, three things were already clear. The application model was completely different. UI manager and action group were gone entirely, and the action callbacks pattern had changed. So from just those three things, it was obvious adapting the old code would only preserve updated assumptions. So the project was rewritten from scratch. Now let me talk about what GTK4 gives you on the other side of that decision. In old Jollpi, detecting external file change was fully manual. I had to calculate an MD5 hash of the file content, store it, and compare it every time the window received a focus in event. And because Python 2 had different model availability depending on the version, I had to wrap the hash function in a try except. Try hash sleep MD5 first, fall back to the old MD5 model. It worked, but it was unreliable. Focus in event is not the same as file chain. Now in GTK4, Gio.FileMonitor handles all of this automatically. You can call a monitor file on a Geo file object, connect to the change signal, and you're done. It detects modified, renamed, and deleted, each with a different event type. So Jollpi can respond differently depending on what actually happened. So this is one of the clearest examples where the rewrite simplified the code, not just modernized it. Next is search, was another area that took significant time. And this is where I want to be honest about how I learned. In Jollpi 2010, search was built on GTK-SourceView's iterator search APIs. I use GTK-SourceView into forward search and iter backward search, standalone function, synchronous, no match count, no regex support, wraparound had to be handled manually by catching exceptions and resetting to the start iterator. Now in GTK4, GTK-SourceView provides source context, a proper source object with async forward and backward search, real-time match con, built-in regex, word, and case-sensitive options. But understanding how to implement async, uh, implement async search in Python took me quite a long time. I learned a lot by reading the GNOME text editor source code. I'm grateful that I can still make sense of C code little by little and understand the patterns behind it. And I translated that into Python for Jollpi. So that process, reading C source code and implementing it in Python, was probably the part that took the most time in the entire rewrite. In Jollpi 2010, the find and replace dialogues were separated windows built with Glade to show the find dialog. I had to set it transient to the parent window, check if it was already visible, and call show out, separated window, separated flow. In GTK4, I use GTK.Revealer for the search and replace navbar to show it. One line, set refer child true. To hide it, set refer child false. The panel slides in inline without interrupting the text area. I discovered this pattern by observing the behavior of the genome text editor. I noticed it had an inline search bar that appeared without a spared window. And after checking the documentation, I found the GTK-Revealer and implemented it in Jollpi. For the status bar, I use GTK overlay. The status bar class subclasses GTK overlay directly. A label appears over the content, showing line and column position. Then auto hides after 2 seconds using glide timeout. And dialogues in Jollpi now serve only for purpose alerts and message. Everything else is inline. One more thing, GTK4 gives you that GTK2 did have at all. CSS styling system. In GTK2, I didn't touch styling. I just follow the system time. There was no easy way, I think, to customize the interface without diving into theme engines. And in GTK4, you can style your application using standard CSS. The same syntax anyone familiar with web development already knows. No extra libraries, no additional dependencies. And for Jollpi, I created a small custom CSS file. I defined a custom grade color palette like Abu Quad, Abu Sedang, Abu Gelap, Indonesian names, yes. And I applied them to the header bar, buttons, and window background. The goal was a neutral gray that works on both dark and light system themes. It's a personal choice, but having that option at all is something GTK4 made easy. Yes, here's what the two versions actually look like side by side. On the left, old Jollpi, simple, minimal, built by a college student learning Python and GTK on his own. On the right, Jollpi 2025, same philosophy, lightweight, minimal dependencies, but rebuilt on a modern stack with a cleaner interface. 15 years apart, same project, but different paradigm. Now, the most interesting challenge I encountered during the rewrite, uh, Jollpi supports multiple tabs. Each tab can open a large file, sometimes up to 1 million lines. Uh, File loading is async using GTK source file loader. That part works fine on its own. But what happens when you have multiple large files loading at the same time, and in another tab, you want to search or replace text? With naive async, where all operations run at the same priority, the search starts feeling sluggish. The UI is technically responsive, but the search interaction lags because the file loaders are competing for the same scheduler time. Async alone is not enough. When everything runs equally, search still lags. The solution was understanding GLib's task scheduling model. GLibs has a priority system for async operations. By default, most operations run at a priority default, but you can explicitly set a lower priority for background work. And for Jollpi, I set the file loader to run at a glib priority low. This means the glib scheduler always gives search operation, which run at priority default, higher priority than file loading. The result, even when multiple large, uh, even yes, the time is apa? Come on. Please type in the chat. Please type in the chat. Second, modern GTK replaced a lot of things that used to be manual. Third, I think alone is not enough. Yes, yes. I think alone is not enough. Priorities matter. GLib priority system is the key to keeping your application responsive under real condition. The documentation lists the priorities. Experience tell you when to use them. Okay, that's called my presentation. Thank you very much for your time and attention. Jollpi available on FlatHub, and Mancat SSP to Parquet Converter is available on FlatHub too. Feel free to explore the project. If you have any question, please type them in the chat. If sometime comes to my letter, don't hesitate to reach out of afterward as well. Thank you. Have a great day.